This naturalrefrigerants.com article is being read by an automated voice. High-temperature heat pumps. Standardized at up to 130 degrees Celsius, with demos pushing beyond 160 degrees Celsius, says Danish Technological Institute. By J. O. Haraldson. Published July 14, 2026. Projects reported by European suppliers indicate that high-temperature heat pumps, HTHPs, are becoming standardized for outlet temperatures of up to 130 degrees Celsius, 266 degrees Fahrenheit, with demonstrations pushing temperatures beyond 160 degrees Celsius, 320 degrees Fahrenheit, according to Martin Pihl Andersen, a consultant at the Danish Technological Institute, DTI. Andersen outlined HTHP technology trends over the past year based on data from more than 40 projects in 14 countries during a presentation at Vaterus Heat Pump Forum 2026. The event took place June 16th to 17th in Turku, Finland. Project 68, part of the International Energy Agency, IEA's collaboration program on heat pump technologies, tracks supplier-reported HTHP technologies and demonstration data, including temperature limits, system capacities, refrigerants, and cost indicators. The DTI is curating the public database and providing annual updates. Running from June 2025 to May 2028, Project 68 builds on Annex 58, IEA's first HTHP database initiative. In Project 68, we see a refrigerant shift happening, with natural options representing 75% of the reviewed portfolio, Andersen said. Frequently used natural refrigerants include CO2, steam, hydrocarbons, and ammonia in ammonia water systems. For every HFO HTHP, there is a natural refrigerant alternative. The event. Atmosphere's founder and CEO, Mark Chassereau, was the keynote speaker at the Vaterus Forum. He highlighted the state of clean heating and cooling, citing the company's 2025 report, Refrigeration, Commercial and Industrial Refrigeration with Natural Refrigerants. The report estimates that 5,650 industrial sites in Europe use transcritical CO2 systems as of December 2025, while 4,100 use low-charge ammonia systems. Atmosphere is the publisher of naturalrefrigerants.com. In addition, the forum featured sessions on opportunities created by environmental targets and EU regulations, along with case studies of natural refrigerant solutions. Presentations were delivered by representatives from Vilter by Copeland, Johnson Controls, GEA, Mayakawa, and Everlens, formerly MAN Energy Solutions. It also included a tour of Vaterus's heat exchanger production facility. Emerging trends. The HTHP data, supplied by more than 55 technology providers, naturally divide into three categories. Standardized products with outlet temperatures of up to 130 degrees Celsius with capacities from 300 to 1,200 kilowatts, 85 to 340 tons of refrigeration. Custom modular systems covering temperatures from 160 to 200 degrees Celsius, 320 to 392 degrees Fahrenheit, with capacities from 0.5 to 10 megawatts, 142 to 2,840 tons of refrigeration, and custom steam cycle projects with temperatures from 150 to 300 degrees Celsius, 302 to 572 degrees Fahrenheit, delivering capacities from 1 to 100 megawatts, 284 to 28,400 tons of refrigeration. The standard range includes skid-sized heat pumps for district heating, with specific investment costs typically running below 600 euros per kilowatt, $2,400 per ton of refrigeration, with relatively limited variation across projects. The custom modular systems often use hydrocarbon refrigerants with an extra compression stage or a cascade configuration to support up to 200 degrees Celsius steam at 12 to 14 bars, 174 to 203 pounds per square inch. Variation in specific investment costs increased, with suppliers reporting between 400 euros to 1,300 euros per kilowatt, $1,600 to $5,200 per ton of refrigeration. The upper end of the temperature range includes very large custom steam generation systems using Stirling cycle concepts and dedicated steam compressors, Andersen explained. Specific investment costs range from 150 euros to 900 euros per kilowatt, $600 to $3,600 per TR. The application/roadmap. Andersen outlined the industries represented in Project 68 and estimated when preferred HTHP technologies are expected to become established. The food and beverage industry accounted for 33% of the projects, Materials applications such as drying processes, 19%. Pulp and paper demonstrations, 16%. District heating applications above 100 degrees Celsius, 212 degrees Fahrenheit, 12%. Chemicals and refinery, pharmaceuticals and wastewater treatment each accounted for 5%, while other uses made up the remaining 7%. Preferred technologies for systems operating below 120 degrees Celsius are already established, Andersen noted. He expects meaningful standardization for outputs up to 160 degrees Celsius within the next 2 to 3 years, followed by those operating above 160 degrees Celsius by the beginning of 2030. For this to happen, compressor manufacturers need to validate performance and reliability at the higher discharge temperatures, Andersen told naturalrefrigerants.com. He also noted that stable, favorable electricity-to-gas price ratios will incentivize standardized designs. Moving the market. Our heat pump test center at DTI is building 2 compressor test rigs for what we feel the market is missing, Andersen said. The Scotty rig will test steam compressors at up to 23 bar, 334 pounds per square inch, of pressure with discharge temperatures up to 350 degrees Celsius, 662 degrees Fahrenheit. For both natural refrigerant and HFO compressors, the Marco rig supports testing with suction pressures from 1 to 15 bar, 15 to 218 pounds per square inch. Discharge pressures of less than 35 bar, 508 pounds per square inch, and temperatures of up to 200 degrees Celsius. The HTHP test rig sandbox supports plug-and test evaluation of up to 2 megawatts, 567 TR systems with an available electrical supply of up to 1,400 amperes. Quotable: the thermodynamic and engineering groundwork for delivering industrial heat electrically at scale is largely there up to 130 degrees Celsius and to 160 degrees Celsius for some instances, Andersen said. What's needed now is the accumulation of trust through more operating hours, transparent performance data, standardized offerings, and proven integrations that reduce the perceived risk.